It's Bob Shep here, and I enjoy doing segmented turning. And one of the pet peeves that I have about segmented turning is making sure that all the joints line up. And for several years, this was a real concern to me. And then eventually, I found a solution. When I start a segmented piece, I take the waste block at the bottom of the vase, for instance, and I will divide it into the number of segments, either 8 or 12 or 16, and I mark those on exactly on the waste block. Then as I add my rings, I line them up with the markings on the waste block. And eventually when you get farther and farther away, you can't see to line them up, so they have a tendency to drift off in one direction or another. So what I finally did is I simply mounted a laser above my lathe. I have it set up so that it goes dead center down the center line of the lathe, as you can see here. Right from the tailstock, following across the tailstock, right up to the top. Now, when I add a new ring, I know that is in an alignment with the waste block at the bottom. No matter how far away it is, it's always dead on. When I first started turning, I was having a problem sharpening my chisels. So I was advised to get a jig. This one happens to be made by One Way, and it does an excellent job. The angle is always true. You can't ask for anything better. But the problem that I had with it was that whenever you set it up against the stone, it always took you 4 or 5 tries to get the angle right. And to me, I would rather be turning than fiddling with trying to find an angle. So what I eventually did is came up with a system so that the jig and this cup at the bottom are always the same distance for a particular chisel. Now, if you look at this chisel, you'll see a red band on it with a number 3. So what I do is I go to the back of the grinder where I have 4 different wires. I lay it in to the pocket, bring it up so that it's touching the grindstone, lock it into place, and I know that I have this socket this right distance from the grindstone. The number 3 simply means that I put it into the 3rd notch on this portion of the jig. And then it's simply a matter of putting it together, making sure that you have your distance, setting up your grinder, as you can see, done. 1 try, no wasted time. Some of you may have a filter in your shop, and it will look like this. It has a series of pockets in it. And when I got my filter, everything was fine, of course, until it got dirty. Then I tried to vacuum it.
Very frustrating to try and clean the dust out of that because you can't get down into the pocket without the vacuum cleaner sucking the fabric into it, and you just never get to the bottom. So, solution had to be made. What I came up with was a pretty simple device. It's just a piece of ABS pipe, a cap cap put into the front of it, the slot cut across it, and in the side of the pipe I cut notches. Not all the way through, just to allow the air to flow in. Put that onto the vacuum cleaner. It doesn't take long to go through, and you notice there's hardly any dust in those pockets compared to the others. So, simple, you can use your filter time and time again.
This is my version of the Trent Bosch video turning hollowing system. Basically uses a cheap little, I guess $20–25 web camera from Amazon and my laptop. A lot of guys use a sheet of Mylar, but I'm cheap, so I use Saran wrap. So depending on what diameter you want, so I'm just going to do the whole outline, the whole holder here. So as you can see, the outline follows the whole cutter, and also here the tool holder as well. So you can see if you're going to rub that on, you know where everything is. So then when you put it in, and it doesn't matter whether you're in here cutting on the side, like using this part of it on this side, or if you go into the bottom and use the very tip of it, you always know where your cutter is, right? Working on the bottom here. So let's fire it up, and Stu wants to see some tips. So that's pretty much it in a nutshell. And there's our cutter again. Yep. And depending on the wall thickness you want, is where you put the black line.
Yep.
Like I say, I would use the outside edge of the Sharpie, not the inside. So when the outside edge, I'll do it on the top here so you can see. So when the outside edge, you can see there. When it's on the edge, that'll give you that much of a wall thickness. And here, we'll do this so you can see how that cutter would follow on the inside, right? And you can see it uses, probably better than a third of the cutter. With a laser, you'd have to keep changing your laser to whichever part of the cutter you were planning on using.
Okay, welcome to my shop. So today I'm just putting together a quick video on some quick tips and jigs to work with a drill press. So as you see, a drill press usually comes with a metal table, and it takes one hand to run this, takes another hand to run the switch, and you got the lights on and off here so it takes a lot of hands to do this stuff. And if you have a piece of material down here, it needs to be clamped down, and so one of the first things you would probably pick up would be a vise. So you can clamp a piece of work in the vise, clamp the vise down to the table, and then you got your hands free to do whatever up here. However, for woodworkers, it doesn't really make it too handy, because we want to be able to maybe hold a piece of wood or work on it on here and have one hand free to operate the lever. So what I did on my drill press is I made a table. Basically, it's just a piece of plywood with a notch cut out of it. And I put a couple of bolts down through. Okay, so on I incorporated a couple of T-slots so you can run a fence back and forth. And then one of the things I found on the back of the table, when I'm working with small pieces, the vibration of the table, pieces would fall off. So I put a little channel around here just to hold the pieces in place while I'm working with it. Okay, in addition to that, I needed a way to hook up my dust collector hose. So I mounted this bracket on here. It's just bolted on underneath, and it's adjustable this way and back and forth. You can lock that down, loosen this nut off here, and you can swing this around so you get a lot of adjustment wherever you need it to be. And you can run the hose through this 4-inch hole and set it up so that it works with wherever the drill press or whatever you're working on. You can put the hose where you want it, and that really works well. And it just swings right out of the way when you don't need it, so that you have the full access of the table. Another thing I noticed is when I'm working with the drill press, and if you start the drill and you have a problem, you have to take one hand off of whatever you're doing to turn the switch off. And to me, that always seemed to get in the way of having to do more work to secure something, or to, just in case something goes wrong. I figured that I'll put on a switch. So if you look down here on the floor, there's a switch, a foot switch. And with this turned on, the foot switch actually works the drill. So if something happens on the drill and you have to stop it, you just step away and the drill stops. I always shut this switch off before I take any tools to the chuck, because that way if I'm inadvertently stepping on the switch, the drill won't run. Okay. Yeah, right. So the next thing is it is a drill press. So primarily when we're working with a drill press, we need to have our drill bits. And I'm sure I'm probably like a lot of people. I have several drill indexes, and I'm always looking for the right drill, but I can't have them on the table when I'm drilling because it's kind of unhandy, and I don't have a lot of space to put them underneath. So I was online one day and I seen somebody else's idea where they said, we'll make a little table for the drill bits. So I took a block of wood, drilled a hole in it, cut it on the bandsaw, and I put a couple of stove bolts in there, like that. And so now this hole is sized to fit the shaft. So just make sure I don't have the wire underneath there. Block on there. And do the lock nuts up here. I can set this up high enough so that it's out of the way. It's up out of the way, and it gives me a good place that I can set my drill indexes on. It's got a little channel around there, so if it vibrates a little, they don't fall off. But it sure makes it handy to have all the drill bits right where I need them when I need them. So now, if I have something clamped to the base here, if I had a block of wood and I had to hold it with one hand, I can work it, and if I step away, it automatically stops. So that's for the drill press. One of the things I found as well, I put a T-channel on here, and for times when I want to have a block of wood on here and I want to drill the holes at exactly the same place every time, well, I can put a stop block on here. This stop block fits on a T-slot, and because it has a notch in it, the notch fits over the bolt, and I can set this wherever I want it to be. And I can drill that piece of wood, and I can drill that one. It'll be, all the holes will be in exactly the same distance based on the stop block. Nice thing about this particular little stop block jig is that it also works on my bandsaw, because on my bandsaw I have a T-slot on the side of the fence, and so I can slide this in the T-slot on the fence and do it as a for relief cutting. If I'm using the miter saw on the bandsaw, I can set this up along the fence to run a piece of wood on, so that when I take it through the saw, there's that much clearance between the piece when it goes through the saw, so it won't bind. Also, if you're cutting on a, if you're wanting to drill on a drill press and you want to drill a round object, well, you can make yourself a little jig like this. It's just a piece of plywood with a couple of pieces of wood that were cut on a 45. You set it on your drill press, and you can put the round object in the piece, and it'll make it easy to hold, so you can drill it exactly on center. Turn this on. You can see this particular drill press has a laser, so you can line this up so it's directly in the center. And if you had this clamped to the fence, then you could drill the holes all the way along exactly the same location, perfectly centered. So it's nice to have a little jig. If you have to do a whole bunch of small rounds, you can make a jig like this, which is basically the same thing. It has a little V-notch, but you can put the piece of wood in there, slide it underneath the clamp, spin these clamps down, and now this is clamped to here. So now you can drill a hole, loosen the clamp, drill it back and forth, and it'll stay perfectly on center, and it'll hold it down so you don't have to hold it with your hands. Just another little jig. And for hold downs, I made these little hold down bars. They're just a piece of, this is a piece of oak. It's got a little bit of sandpaper on this side and a little bit here. You can run the T-slot, run it in the T-slot, and if you needed to hold a piece of work, you can slide it up like that, tighten this T-slot down, and it holds the work nice and solid. I've got a couple of these so I can clamp it on one side or the other, and it's just really, really simple. So that's another improvement. Okay. I had a project one time where I needed to hold something on the drill press table, and I didn't want to have to clamp it to the table every time. So I made this little jig. All it is a piece of plywood with a stop fence on here, so it goes to the same place on the table all the time, and I can clamp my piece of work in here. If I needed to put a stop block on here, I could mount a stop block, and that way when I slide this in, it would be exactly where I need it to be every time. I could line this up with the laser on the drill and put a pencil mark on here, but every time I slide a piece of wood in here, it would be exactly the same depth. Very simple. Making these little knobs is just a piece of wood with a quarter 20 insert in it, and a stove bolt, or a stove bolt. And yeah, makes a nice little jig. Okay, we'll take a look at one of the jigs we got set up here on the lathe. So that's this is a counterbalance that I found this in a book by Barbara Dill for doing offset spindle turning, where you're doing it between centers. So this is a step center. It's just your standard step center. You could be a spur drive, and it fits into the Morris Tabor, but you'll notice that I've also got a chuck mounted on here. And with this chuck, this chuck is holding the counterweight. So this is a counterweight that has I have a bolt on here where I can adjust the amount of weight that I put on it, and I can change the location. I can put 2 bolts in to adjust whatever offset I need. And the interesting thing is that this is a Morris Taper 2 extension. So it's just a Morris Taper 2 here, and it has a Morris Taper 2 extension. And with the Vicmark chuck and with the jaws fully open, there's enough room for this to fit inside the jaws so that the Morris Taper can go right in and lock into the spindle. Morris Taper sticks out far enough that putting this this counterbalance on is it'll then spin with the wood. And one of the things that Barbara Dill mentioned is that as you're turning off-center spindles, the weight changes. So if the weight center of gravity changes, then the counterbalance weight will likely change as well. So one of the things that's really nice about this setup is if the weight changes, all you have to do is just slack this off, move your counterweight, tighten it again, and then try out and see where the center is, because the heaviest part will always tend to go to the bottom. So once you find out where the heaviest part is, you can lock this opposite where it needs to be, and it'll automatically balance. So typically when this is going round and round and you shut the lathe off, it will always find the heaviest spot will go to the bottom. So you make a few adjustments until it stops any random place, which means you're balanced, and it makes it a lot easier to do spindle turning with offset spindles. And that's all it took was they call this a Morris Taper 2 MT2 extension. Another little jig or tip, I guess, is on my lathe. I've got a Vicmark lathe, and this is the top of the lathe. There's not much room for anything to sit on here, which is a good thing because things could fall off. However, I find a lot of times when I'm doing a lot of small work, I need to have some place to put some of the pieces, some of the tools. So what I did was I took 2 of these twist magnets. One of them isn't strong enough. 2 of them works perfect. Because this is cantilevered a little bit, it'll hold the things that I'm working on for the day, like small pieces of wood, maybe the odd drive center, sometimes a tool, definitely pencils. And it's just handy to have the things that I'm working with on the lathe at the time. Okay, one of the things I made for the live center to prevent me from banging my elbow in the live center periodically is I took a piece of golf ball and I drilled a hole in the golf ball and tied a string through it so I can hang it on the side of the lathe here, so it's always available. And it's just long enough that I can reach over and put this on the end of the live center. So basically, there's your live center, and this is a 3/4 10. I just drilled the hole big enough so that this just slides over. Friction holds on there, so when it's sitting on the tailstock, I don't have to worry about bumping my elbow into the sharp point. Okay, I think that's about all I've got for today. So I gave you a couple of tips on the drill press and a couple of tips on the lathe.
So welcome to the shop again. How many of us have an interesting piece of wood that we'd love to cut, but we don't have a bandsaw mill, or we don't have a bandsaw, or it's too big for the bandsaw, something like that. So I've made this little jig out of simple 2x8s and 2x4s. I left a little gap here beside the vertical, and on there I can fit my chainsaw that has something called a beam machine attached to the blade. Just gives enough clearance for the blade here, and just there's a bolt that does up from the other side. I like to use an electric chainsaw in the shop because it doesn't make any smell. It's relatively quiet and it's handy. So to use this, all I do is set up my piece of wood, and I can see it's already got some cracks. I'll put a couple of simply made wedges underneath just so it's not going to move too much. I can eyeball where I want it, and away I go. Cut apart relatively easily, and I can let it dry, or I can take it to the lathe.
Go for it. Hi there. Gathered here at my shop, Stu Bremner, at my shop here. I just wanted to show you a few things we're going to look at today, some trinkets and things that kind of make your job a little easier and a little nicer to work with. And I picked up this little unit here from a friend of mine, and they're actually pretty handy for being able to mount something on. In this case, I built a flange to screw a 30. Okay, here we are at the lathe, and as you all know, whenever you're working with your lathe, it's a very common habit to take your tool that you're working with, whatever it may be, and lay it on the bed. Big mistake. I really frown on this. I really try not to do it. I've come up with a rack idea along the side here. In this case, with my robots, I got a spot that I made a little, there's a little hole in this bracket in the top of this headstock, and the idea of that is actually to hold a light. But I built this table and a lock on it, as you can see, to keep it from turning. Anyway, you can get a position with this, and on the table I've taken a piece of PVC and, ABS, and I've cut the side out of it so it makes a cradle for the tool to sit in, and I have two of them, and that holds my tool from rolling off. It's not like having it on the bed where it gets knocked over, and when they go on the floor, they always like to hit the pointy end, and we don't want that. Another thing that I've added to this table is a couple of magnets, which is very handy to hold simple things like a ruler, any of your small tools that you have. Okay, in this particular case of my lathe, I could bolt on a piece of angle iron from one end to the other, and I put these pieces of pipe lined up that I could fit another bracket into. In this case, I got a flat bar that sits here where the magnetic base for the light will attach to. If I want it closer to go over here, I just have to loosen this off, take the light off, take this out, move to a different position, then I can put the light here, or another one even closer, but normally I usually keep it about here. And you also see I got another spike sitting up here with a hole in it. That's to hold the bracket to put my vacuum housing on. This sits in here like this. And I can move this all around to where I need it. for my dust collection. Okay, on this end of the lathe, I put myself another little tray, a small lip on it just to catch things from rolling off, padded surface, but I've also added another rest for the tools. And what I did with this one was I capped it on the end because the tool can stick right through, and it's a common place that you walk past. These things are sharp. I found out the hard way. So what I did was I just capped the end so that the tool will sit in here and it won't go right through, and it's a little safety piece.
Perfect.
This is adjustable to go different places. Easy to take off if need be. There it is.
Okay, this is my latest addition to my tool bench for my lathe. I needed a place to access my tools a little bit more safely and efficiently. So I came up with a modification to a design I'd seen online where the tools can be picked up and just dropped in, and they go into their proper location. And because I have quite a few tools, I needed a place to be able to put them all. So not only do I have it on the front side, but I also have the latch on the back side, so I can open up the back side as well and get access to all my tools. So another little tip is when you're going to do some drilling, you can take your tailstock out, you can put in a Jacob's chuck, but the one of the things I found with the Jacob's chuck is it is a 3-jaw chuck, and your bit can be just gripped on 3 sides. It may not be perfectly center every time, and it's this far away from the support, so it could be a little wobbly. So one option to get around that is to get a Morris taper 2 to a Morris taper 2, slam that in here, and this is a 1/4-inch collet, and the 1/4-inch collet is driven in nice and tight, and now you still have the functionality of screwing in and screwing out. The drill bit is secured on all the way around. It's exactly on center every time, and you can use different size collets for different size drill bits, which gives you the ability to do a starter hole really accurately if that's what you so desire. Anyway, that's just another quick tip to change the drill bits. You just need to use the knockout key. Take the collet out, replace the collet with the collet of the different bit, and the collets slip inside Morris taper 2, and you can get these in various sizes. I have them up to 1/2 inch. Okay, another little jig that we've got that I like to use with my lathe is for turning stave boxes. Basically, you make the stave in a cylinder, and you take the inside dimension of the stave box. I measure this off. I put a piece of plywood on here suitable for the inside dimension of the stave box. On the back side of here, I've just got a piece of wood, and I put a dovetail on it, and I screwed my plywood to the dovetail block, drive block, and I made this diameter the size to fit whatever stave box I'm working with. This has 2 screws, so it can come off, and another size can be put on. And on the end, I also tapped it 3/4 10. So I have 2 of these. One fits in the chuck like this, and so that'll spin nicely on the headstock. And when you push the stave box up against this drive disc, it will drive the disc. Then you bring the tailstock up, and you'll see that there's a mating spigot on this tailstock. but because it can threaded 3/4 10 onto the live center, then it'll spin. It'll spin with the headstock when the headstock spins. So if you had the box in between there, it would spin and spin fairly true, and you could service the outside of the box, get it whatever shape you want, and you're in business. Fairly simple, pretty straightforward, and it works. That's about it.